Hello, and welcome to this AWS Tech Talk on AWS IoT device services, specifically the topic of bringing intelligence to the edge for smart home applications. My name is Ian Perez. I am with a global IoT business development team here at AWS. And today I have the distinct pleasure of two guest speakers, Bharat Patel, CTO and co-founder of Cradlewise, and Jerome Shang, business development director of Edge and IoT at NXP. Welcome, Bharat and Jerome. So as far as what we plan to cover in today's webinar, a couple learning objectives. One is going over the connected home market, giving you an idea of what that looks like today, along with some of the leading use cases. We'll then pivot into AWS IoT device services and come to understand how they can support a broad array of application use cases for the smart or connected home. I'll then pass it over to Bharat, who will talk about Cradlewise and their Smart Cradle application and device and how AWS IoT has helped enable that. And then we'll pass it off to Jerome from NXP, who will walk through a couple of hardware solutions that can help match your specific smart home application requirements. We will try to save some time for Q&A at the end, but if you have any questions as we're going through this, don't hesitate to enter those into the chat box. We'll try to answer those in real time as best we can. Let's go ahead and kick off. We'll take a quick snapshot at the connected home market just by the numbers. If you look at some of the IDC forecasts that are out there, they're forecasting about 833 million smart home devices to be shipped by end of this year. That's roughly up 27% from last year. Looking more towards the horizon, by 2023, we're looking at 1.56 billion devices with a compound growth rate of almost 19%. So pretty healthy growth numbers there. Another interesting fact is Vision Mobile. They do an IoT study that estimates about 25% of the total IoT developers out there, that are about 4.2 million, are focused in the smart home category. So a lot of momentum in the space. Needless to say, we're excited to be a part of that. However, it's worth calling out some of the challenges and opportunities that we do see in the connected home market. Call a few of them out here. One, just starting from top left, how to differentiate in a crowded market. There's an overwhelming number of devices, even in the same category, that are coming out. So differentiation is certainly instrumental in terms of providing a viable product that's certainly attractive at launch, but also for the long haul. And that kind of feeds into the second point, which is how do you improve the customer experience or enhance the customer experience while keeping costs low? And costs factor in both in terms of the actual cost of goods sold from a customer perspective, and also cost of operating or maintaining the actual service that the specific connected home product delivers. Interoperability has been yet another area where we're starting to see some challenges as well as opportunities as more vendors come into the household with different devices. How do you move away from single scope functionality on a per device and start to actually integrate for a more comprehensive or richer experience? And then from a cloud infrastructure backend perspective, for those of you that are really focused on developing products for the connected home, how much effort or how much consideration are you giving to the actual cloud backend infrastructure, your core infrastructure that's powering all those devices and the applications that's running on top of them? Security, I think we can all agree, is absolutely paramount, both from an operator perspective as a good practice, but also in terms of ensuring customer trust and maintaining that trust. And then in terms of innovating on top of your products and the applications that are running in the connected home, how can you leverage edge-based computing? There's a lot of discussion about edge-based computing, specifically machine learning and inference at the edge. And so we'll talk a little bit about how that can actually help stimulate some innovation capabilities above and beyond what you might already have in scope for a connected home product. In terms of use cases, I think we're all pretty familiar with some of the main use case themes that are out in the market today. We tend to categorize them into three. On the left, there's the home automation space, which can range from common smart light bulbs all the way to personal assistants in the home to connected TVs or smart TVs. In the home networking space, any mix of connectivity appliances, Wi-Fi routers, modems, and cable set-top boxes. And then in the home security and monitoring space, things like internet-connected cameras to smart door locks, thermostats, and even smart utility meters. So those are kind of the three general categories or themes. We'll go into a little bit more of the trends and opportunities for each of those themes, starting with home automation. One of the dominant trends that I think we're all seeing is the integration of voice control for natural language processing embedded into smart devices. And I think the idea is is to provide a more intuitive user experience for customers, regardless of how they're interacting with a specific device in the connected home. A second trend is, again, interoperability. And in some cases, we see the interoperability happening through some of the home personal assistants that are basically providing that voice control capability as well as a central hub function. Again, in the spirit of providing a richer experience for customers as they use more devices in connection with one another. And then the other intended outcome here is just really providing ease of use, right? Ease of use, better customer experience with ease of use is kind of the holy grail that the market, I believe, is aiming for. For the home security and monitoring space, I think this is where we're starting to see a lot of rich media processing or the needs for rich media processing as audio and image video recognition comes into the fold. This is where we see machine learning and inference at the edge really starting to pop its head a little bit more, as you can think of some of the advancements in object detection and how you can apply those at the edge versus in the cloud. Really starts to kind of resonate with some of the offerings that are out there. Home surveillance is a good example. Again, being able to do basic object detection of people or things to perform certain functions. Those functions perhaps require quick response time. So you're starting to look at use cases where you don't necessarily want to incur a round trip back to the cloud to do some analysis of that device data, but instead actually collect it locally, process it locally, and analyze on that, and perhaps further down the processing stage, maybe ingest some of that data back to the cloud for mass aggregation or model improvement. And then energy management kind of comes into the fold as well, whether that's water detection or water leak appliances or gas leak appliances, or even just pure utility energy management. And then we come to the home networking space, where we're really looking at how providers, operators are trying to improve the customer experience, really optimizing the network performance. And this isn't only from a optimizing the network up to the connection drop to the home, but actually within the home, as we start seeing, again, mass proliferation of different devices in the connected home coming into the household. How do you optimize for that, regardless of the connectivity protocol? It could be Wi-Fi, it could be Zigbee or Thread, etc. And all while doing that with a reduced customer support cost is, one of the key aspirations, if you will, for this space. So with those use case themes in mind, let's kind of pivot to AWS IoT services and how they actually relate to some of the smart home applications or use cases that we just reviewed. We'll start with a quick glance of the AWS IoT architecture. A little bit of a busy slide here, but I'll try to walk you through it from left to right. From a topology perspective, we're really looking at two different domains. On the left, we have things that sense and act. So these can be, again, devices for any of the use case themes we just covered that are in the home. Might be a smart door lock. It might be a thermostat that's acting as an endpoint, and that endpoint might have direct connectivity to the cloud and therefore direct connectivity to your backend application, or it might have connectivity through a local gateway. That gateway might be an intelligent home hub that's aggregating various endpoints and perhaps providing some richer functionality at the edge or at that location, in addition to aggregating the actual traffic and forwarding that traffic back to the cloud. As we shift to the right side of the slide, we see various silos there where certain functionality can be implemented. First and foremost, we start, again, going from left to right. How do you actually take devices that are perhaps in the hundreds of thousands or millions and securely connect them to the cloud and allow that messaging to actually flow bidirectionally? And then what do you do with that messaging in terms of either applying certain policies for audit control or protection. Perhaps you're actually using that messaging to detect when you actually need to update devices, do firmware over-the-air updates, or maybe it's just for raw processing and analytics, where you can kind of feed that IoT-generated traffic from devices in the home to the corresponding back-end, business applications that you have that are trying to derive meaningful insights back to the business or back to your customers, for that matter. So if we start mapping specific services from AWS IoT that correspond to each of those functional domains, if you will, you'll notice there's about 9 different services that we have in the mix. We certainly won't have time to cover all of these in detail today. To be a little bit more direct, I think we will spend quite a bit of time talking about what services are relevant when you're talking about in the home type of devices. And that's really where we focus on AWS IoT Greengrass and Amazon FreeRTOS. So that's where we'll spend a little bit of time today. And I think you'll kind of hear the messaging from Bharat and Jerome resonate with these services in their portion of the presentation. Just to call out, you'll see AWS IoT Sitewise there that's mentioned just for comprehensiveness, but does not really play a role in the connected home space. That's meant more for the industrial IoT type of use case or use cases. So I will just contradict myself for a second and cover IoT Core, AWS IoT Core, since it is rather instrumental, regardless of how you're connecting devices at the edge, whether that's through Greengrass or whether that's through Amazon FreeRTOS. AWS IoT Core is really the front and center gateway that allows devices to securely connect to the cloud and then enables you to actually process whatever traffic is coming from those devices and forward that traffic to corresponding service endpoints for processing or for aggregation or for filtering. So bear that in mind, that AWS IoT Core, regardless of how you're trying to connect your devices at the edge, be it in the connected home or elsewhere, IoT Core is basically that central gateway that allows for secure connectivity and messaging. And how it does that is through a couple of different sub-services, if you will. These are some of the features of IoT Core. One is an identity service, which allows you to through certificates, authenticate your devices that are connecting to the cloud, making sure that only the right authorized devices have accessibility into your IoT service backend. There's also a device gateway and a message broker, which uses standard MQTT protocol for pub/sub messaging. And that further feeds into the rules engine, which, as the name implies, is basically a way to implement certain policies that will forward specific IoT traffic to corresponding endpoints. That endpoint can be Amazon S3 if you just want to store messages as logs, or maybe you want to forward it to Kinesis for streaming and analysis. You have quite a bit of flexibility there in terms of where the rules engine can forward IoT message traffic from. And then lastly, we have the device shadow and registry, which serves as a means of preserving persistent data states for your actual devices during periods of intermittent connectivity, which is something that we typically expect in most IoT scenarios. IoT devices may not always be connected to the back end, and so there's still a requirement to preserve their configuration state. So that's, in a nutshell, IoT Core. Let's switch over to IoT Greengrass, again, going back from the core to the edge. A couple of the functions that IoT Greengrass provides. So local messaging and triggers. So we have a local MQTT broker in Greengrass. And I guess maybe just to take a step back, the best way to describe Greengrass is it is a software-based runtime that runs on top of Linux. So any device, gateway device or hub device that is running Linux and perhaps more than likely has a microprocessor versus a microcontroller-based architecture is very suitable for Greengrass. Once you have Greengrass up and running, it allows you to basically run a lot of the logic you would otherwise run in the cloud locally. So local messaging, again, through an MQTT broker, being able to actually support local actions. You can actually develop your own logic using AWS Lambda and move those Lambda functions to the edge so that they can run autonomously. We also have the ability to support data and state synchronization for devices that are in the connected home, for instance, and connected to that gateway or hub that's running Greengrass. So we have, again, using shadows in a local registry. Security, being able to provide mutual authentication for and authorization for the devices that are connected through Greengrass in the cloud, absolutely critical and an instrumental feature in Greengrass. And last but not least, being able to provide over-the-air updates. And the over-the-air updates are kind of twofold. One is for the Greengrass IoT core environment itself, as well as for any of the Lambdas that you've developed to run your applications at the edge. As we move into some of the more advanced features in Greengrass that will resonate, I think, with today's theme as far as bringing intelligence to the edge, there's a couple things we'll call out here, which is one, local resource access. So Greengrass does allow you the ability to connect your applications running on a hub or gateway to peripherals, whether those are USB peripherals or perhaps serial connected peripherals, as well as conventional connected home devices that are perhaps using Wi-Fi or Bluetooth. And then the ability to actually have machine learning inference running as an actual Lambda function on Greengrass itself. And so basically what we're showing is the sequence of events where on the right, data would be coming in from your devices through Greengrass into AWS IoT Core. You might feed that data into AWS IoT Analytics, which is a separate service that might allow you to aggregate and enrich that data. And then through Amazon SageMaker, effectively create machine learning models that you can optimize to run on leaner hardware devices, if you will. Leaner meaning less memory and CPU than perhaps an industrial type of server on the back end, and move those models over to AWS IoT Greengrass, which would manage the implementation of those models. So gives you kind of an overview of how the sequence of events would take place if you were looking to implement, let's say, an object detection machine learning model from data that's originated on your IoT devices and then pushing it back out to Greengrass. One other quick thing I'll mention in Greengrass is the concept of connectors. So again, in terms of enriching your applications that are running at the edge versus having to enrich them only in the cloud, we have connectors that are available for both third-party services as well as third-party protocols, which you see there on the bottom left. And we also have natural plug-and-play connectors that integrate with some of the other AWS downstream services, such as CloudWatch and Kinesis FireHose, for example. On the machine learning side, we do have 3 connectors that support a couple of different architectures in terms of processors. So we have ARM-based support, we have NVIDIA Jetson support, and we have Intel x86-64 support. So pretty broad range coverage there, and I would say equal coverage in terms of the actual model environments that you're intending to support. As far as the actual future-proofing ability that Greengrass provides, there's a couple of benefits. The innovation curve has been pretty steep since we launched back in 2017. There's a couple of other, and that will continue. There's also a couple of other things that we would call out in terms of legacy support. You can bring your own applications, to the extent that they're able to be ported to any language in Lambda. You can bring those applications and move them out to the edge. We have a pretty broad developer ecosystem as far as being able to have, one programming methodology and being able to run your programming logic both in the cloud and at the edge, full flexibility there. And then the security that AWS typically provides at the cloud, being able to extend that to the edge to ensure, again, security and layers across your connected home devices. So now we're going to just pivot very quickly to Amazon FreeRTOS. So if you recall what I was saying, where Greengrass is really appropriate for more of the microprocessor-based gateway / hub devices, Amazon FreeRTOS is really an IoT operating system for microcontroller devices. And when we talk about microcontrollers, and I think Jerome will get into this in a little bit, we're talking about specific endpoint devices such as a smart light bulb or door lock. Doesn't have a lot of CPU, doesn't have a lot of RAM or memory, and so we're really trying to deliver an operating system that's suited for those devices, but that still provides rich integration for IoT cloud backend services. And so some of the things that Amazon FreeRTOS provides, which I should have mentioned is based on the actual FreeRTOS kernel, is additional libraries for connectivity, such as Bluetooth Low Energy or Wi-Fi, cloud connectivity libraries to provide plug-and-play connectivity back to AWS IoT Core or through AWS IoT Core, as well as some security connectivity libraries with integration with IoT Device Defender, and last but not least, being able to do over-the-air updates through IoT Device Manager. So these are some of the atomic features or capabilities that you get with FreeRTOS, Amazon FreeRTOS, in addition to kind of the basic FreeRTOS kernel that's out in the market today. Why Amazon FreeRTOS? Well, there's a couple of advantages here. One is portability and being able to actually use Amazon FreeRTOS across a broad range of hardware platforms. And again, Jerome will speak to that in a bit. Long-term maintenance, so the full backing of traditional AWS maintenance and support over long periods of time, bearing in mind that most of the devices that go out in the connected home space have a rather long lifespan. We're not talking about 1 or 2 years, but perhaps 7, 10 years and beyond. Constant innovation. We're continuing, just like Greengrass, we're innovating on the FreeRTOS side as well and adding additional libraries as it makes sense to integrate with other backend services that might enrich the product and user experience. From a cost perspective, as the name implies, it's free. There is no charge for Amazon FreeRTOS itself, so there's no licensing. It's pretty much royalty-free and open source. And from a security perspective, being able to really adhere to some of the more stringent security standards to the edge, regardless of what device FreeRTOS might be running on. So as far as how it all comes together, I think hopefully we gave you a little bit of perspective on where Greengrass and Amazon FreeRTOS can run based on MPU architectures or MPU-based devices versus microcontroller-based devices. Again, whether those are in coexistence, where you have perhaps endpoints connecting to Greengrass or endpoints connecting directly to the cloud, they will still feed in through IoT Core, and you have the option of using any of the other AWS IoT services on the back end, as well as other AWS services, be that on the machine learning side, on the compute or database side, and how that interacts with other applications, be they business applications or perhaps third-party applications further downstream, entirely your choice on how to architect that. So in summary, why AWS IoT for connected home? We mentioned a couple of the challenges and opportunities that affect the market today. We really are making a strong push in terms of having easy-to-use IoT technology and services with native machine learning driven insights built in, as well as native integration with Alexa for natural language processing, being able to add that to your connected devices in the home. The pay-as-you-go model persists for AWS IoT services, so fundamentally no difference from how we roll out many of the other services within AWS, trying to keep costs low as you scale. The actual platform itself supports various messaging protocols, so we have quite a few different partners that are offering solutions on top of AWS IoT services to enable multi-vendor scenarios. The IoT cloud backend leverages everything else we've implemented on AWS to date in terms of providing a reliable, secure, and cloud scalable cloud infrastructure backend. So whether you start with 100 devices or 100,000 devices in the connected home, the scalability is there to guarantee a fairly linear scale-out model. And security, as I said, paramount pretty much in all IoT applications, and we try to address that in layers, both from a connection perspective as well as from a data integrity and data assurance perspective. And lastly, we touched on edge-based computing and how some of those capabilities between Greengrass and SageMaker can help really bring machine learning models to the edge for more actionable insights closer to the consumer and the applications. So with that, I will now hand it over to Bharat from Cradlewise. Bharat, take it away.
Thanks, Ian. Hello everyone, this is Bharat here. I'm the co-founder and CTO of Cradlewise. So what we're building here is a smart cradle that provides good sleep to babies and peace of mind to parents. The whole point is we're making a cradle that puts your baby to sleep just as a mother would. And what do we mean by that? So the main feature that the cradle provides is called responsive rocking. And by responsive rocking, what we mean is that when the baby shows some cues that it is about to wake up and it is still sleeping time, the cradle rocks the baby back to sleep automatically. It also uses music to soothe the baby. So in order to do all of this, we also have to take care of the baby's safety, and we should be informing the parents about all the actions that the cradle is doing, as well as allow the parents to control the cradle from a mobile app. So this brings in the AWS IoT. Some of the key requirements that we had in our mind before choosing an IoT platform are as follows. The most important thing is that our parents can be both at home or away, and they should be able to monitor the baby, they should be able to get safety alerts of the baby, and also be able to control the cradle whether they are away or at home. More importantly, all babies are not the same. So we need to learn from each baby, and we need to keep updating our algorithms on the edge. So it is very important to store the various events that happen on the cradle and also to collect a lot of data about the baby so that we can give customized experience to each baby. And that also means that we need to provide over-the-air updates regularly. We also need to handle critical errors and be able to log all of the various things that are happening on the cradle so that we can give very real-time updates to our users. For example, a parent might want to turn on rocking of the cradle. So the parent picks the mobile device, hits the rock button, and then the mobile device sends a message to the IoT endpoint over MQTT, and then the IoT endpoint sends the update to the cradle. So once the cradle gets an update, the cradle starts rocking, and then the cradle updates the reported state back to the IoT endpoint, and then the mobile confirms that the reported state is correct. This is one whole cycle. And this is an example of a remote update. Now let's look at a local version of the same thing. So at home, over local Wi-Fi, the mobile can again send an MQTT message directly to the cradle. But this time the difference is that the local and the remote shadows are synced together so that all the other mobiles are also updated and they all have the same state that the cradle has. So apart from simple control and notifications, as I mentioned earlier, it is very important that we keep learning so that we can dynamically update the behavior so that the cradle becomes better at soothing babies in general. For example, it is very important to understand what are the various moods of the baby, what are the various states of baby's sleep, and what are the kind of schedules that a baby has every day. It's also important to understand what are the various states of the cradle and what are the various states of the mobile, and what is the relationship of these states with respect to each other. Therefore, we have to log a lot of events, and similarly also have to log a lot of data related to various baby actions such as baby waking up, baby's breath rate, baby's rollover, etc. For handling all of the data and event logging, we use local and remote lambdas in conjunction, and send the data to a relational database or to a S3 bucket. Now, once we collect all of these events and the data, the machine learning models are updated on the fly, and all of this happens using the EC2 machines and the S3 buckets. So once the analysis is done, the models are updated in the S3 buckets. Now we are ready for pushing these enhancements back to the Cradle. Sometimes there are also bug fixes that we need to make. So how do we handle all of this? So here is where the Greengrass over-the-air update comes in very handy. So we take all of the new code as well as the new models that is there in S3, and we need to push all of that to the Cradle. Moreover, we need to make sure that we can make target groups so that we deploy these updates selectively. For example, some of the new changes which are probably more experimental in nature would have to be deployed to a very local region first, tried out, and then sent out globally. So since Greengrass backend allows for making such target groups, it becomes very easy to handle all of these scenarios. So just to run you through a simple routine here, AWS console is used to trigger the update, and once a trigger is done, all of the cradles in the target group ask for a permission from the mobile app to update the firmware. Once the permission is granted from an S3 bucket, all of the new models as well as the new code is downloaded, and a constant status update is provided to the AWS console as well as to the mobile apps. Moving on. Yeah, like I mentioned earlier, it's also very important to log warnings and errors. This is from two perspectives. One is obviously to figure out bugs, issues in our own code. The other is to be able to find out issues well in advance so that even before parents complain to us, we kind of have an idea of what's gone wrong and what are they going to talk about. So for that, we also use the alarm systems in the AWS CloudWatch so that the developers get immediate notifications upon a critical issue. For example, you can see here that as soon as the Cradle has a critical issue, it notifies to CloudWatch, and then CloudWatch generates alarms based on some of the rules that we have set already, and a developer immediately gets an email notification and quickly can log in remotely into the Cradle and debug if needed, and can also quickly change the code in advance well before parents observe some of the issues. Some of the example issues that we might have to immediately address is like, suppose we have bad batteries or we have bad motors. So then imagine that we already have a knowledge that something is going bad, and even before users can complain, we might be able to ship hardware or update their software so that the issues are resolved well before they become very critical. So we started our journey with a Cradle because that's where a baby spends most of the time in the initial 2 years. But in the future, we are looking at adding so much more intelligence all across the house. To begin with, just around the Cradle, we might want to add a baby wetness sensor. We might want to add a baby temperature sensor, all of which are wirelessly connected. And obviously, Greengrass core helps to kind of expand and just keep adding endpoints, keep adding devices. And well into the future, we might also have a central kind of a server at each home which connects to all of the various smart devices that help monitor kids, babies, that help also to control some of the companion toys for kids, and obviously connect again to mobiles so that parents can monitor and control all that happens at home. And as you can see, using Greengrass core, it's very easy to expand the current architecture to scale well into all of the future scenarios as well. So yeah, that's it from my side. Thanks a lot. I'll now hand over to Jerome.
Thanks, Bharat. This is Jerome Shang. I have responsibility for cloud ecosystem partnership with NXP, and so it's our pleasure to be hosted with you today. As Jan presented key trends and opportunities, let's step back and understand what underpins them and will improve the time to market. Obviously, investing in the right market simply provides you a strong tailwind. To win, we must, however, understand the real pain points. And over the last year, we've spent many hours investigating the key challenges in IoT along with AWS. And so we then validated the list with executives at our largest accounts and customers in smart home, retail, and entertainment. These customers include top tiers common to AWS. They all agree on this list. We found the cost of implementation of IoT concept is growing substantially without any purposeful effort to provide solutions for these specific challenges. And so when you look at this curve, the hype of IoT here, you realize that the areas of growing cost are actually linked to on-prem data centers, network cost, which is essentially the amount of data traffic that goes back and forth to the cloud that is causing significant growth if not managed properly, the semiconductor cost, where not all industry players have developed IoT purpose hardware platform. Rather, the industry has been forced to reuse costly mobile phone, PC architectures, and data center silicon to meet their needs. We are here to try to solve that problem with AWS in places where you'll have the right product for the right fit. So as customers look to build out their portfolio of IoT products, it's just no longer one or two products, one or two phones. Portfolio now includes 5+ devices per application. They are running into serious challenges in scaling their hardware resources. Hardware engineers are now starting out by selecting the optimal point solution for application meeting the requirements of the AWS cloud service they intend to run. But in the event they pick a point vendor, they just cannot re-leverage this code base for other applications. This is where the scalability of the AWS and NXP collaboration matters most. Some customers have had the foresight to avoid this pitfall by planning their roadmap based on platform derivative approach, the sweet spot where Greengrass and Amazon FreeRTOS provide you with the portability you need. So when you look at the different barriers that we're solving here, the obvious barriers facing IoT was users' privacy, places where NXP and AWS strive with the just-in-time registration mechanism and provisioning of certificates. And as you go up this curve again, you realize that edge computing platform, along with the capability to scale economical machine learning at the edge, would provide most of solutions linked to privacies, low latencies, and managed cost when it comes to communications to the edge and to the cloud. When you're looking at the portfolio is required to underpin those solutions, when you're looking at the scale that is needed, on the left-hand side, you have microcontrollers, what we see as MCUs. On the right-hand side of the spectrum, MPUs, microprocessors. The distinction is made essentially on the capacity of the devices to handle high-level operating systems, those kind of devices that are capable of running an MMU, which at this point in time make them capable of running the Greengrass runtime environment. If not, on the lower-hand side, Amazon FreeRTOS kernels. So, well, the point here is that a core requirement here is to attack the cost challenges at the semiconductor level. We are tackling here the approach of building a full spectrum of processing platforms that service all the different tiers of IoT processing requirements. So we believe there is not one size fits all for IoT. The existing mobile and data center solutions are simply ideal for IoT class products in the home area. Further, if you look here in the middle, we have taken the strengths of each of our processing platforms and developed new class of processing to offer similar performance of typical application processors at lower cost. It's essentially application processing IC fabric with an RTOS to offer greater performance of an MCU for a smaller price increase. And this is what i.MX RT is. And so this is where you see AWS and NXP being uniquely positioned to provide solution for all type of customers application. Would that be low power, high performance, or cost sensitive, but be able for our customers to reuse their software across all. We are also uniquely capable here to bridge the gap from MCU to application processor with RT. And this is supported by the new Amazon FreeRTOS kernel supporting the most advanced secure cores. When you're looking at how this unfolds, you realize that there is some huge traction for edge-based ML across the spectrum. Would we start from Cortex M7 with DSP acceleration, going to M4-based application with multiple Core A53s supported by GPUs, or simply going to massive amount of Cortex A72s, you'll find here the sweet spot of opportunity to run your ML workloads at the edge. Let's spend time a little bit on use cases. So we spent time reevaluating the value proposition fueling the IoT market. The great news is that all key value proposition remain squarely intact, and customers are starting to recognize the real benefits. Voice assistant in the home are offering us great convenience, and now e-commerce is surging on those devices. Machine learning is solving home access control and medical challenges the industry has been attempting to solve for decades. Assisted living are improving safety in the homes. Connected device at your home are providing greater surveillance capabilities for your home or your rest. You see here that there is an intersection point for AWS services at just every single point of connection. Would that be at the gateway level, where Greengrass could run and manage workloads in containers, or would that be at the end node level, where the IoT point of ingestion can manage voice streams and or a significant amount of data aggregation through sensors that would inform IoT device defender or IoT device analytics for that matter. When you're looking at the continuum of processing power required to support those applications, it's important we help you identify what is the best product and service and operating system for the job. We intend to depict here the kind of acceleration that is required or necessary to power built-in machine learning, or to potentially have external accelerator on a need-to-have basis. We would be providing you with the help needed for you to identify which application requires which kind of horsepower. The name of the game here is to understand that would that be Amazon FreeRTOS, Greengrass, and the different connected services, you'll find the right enablement at the right cost point you choose to adopt. As we're further digging inside our enablement matrix, and here with the opportunities that Ian depicted in introduction, you realize that we will be able to provide you the right intersection of AWS services in these horizontals versus the right product enablement on the verticals. We're currently working with AWS to enable relevant AWS services in places where the most efficient. We're trying to make sure that the level of integration of our MCUs and MPUs match the performance expected from the services running at the edge and the end node levels. You will see here at the bottom of this graph what are the intended services that we intend to run on the combination of AWS operating systems and NXP cores. You will realize that i.MX RT, this crossover product here in the middle, is capable of running most of those services hinging on AWS FreeRTOS, but actual MPU fabric coming along with it would allow you to run some significant amount of machine learning algorithm, just like the ones associated to anomaly detection that would be typically useful for any appliance makers to kind of gauge the performance on site of their devices, along with potential telemetry that would allow you to trigger some preventive maintenance or prescriptive operations on the device. Two particular examples I'll take in this webinar are the ones enabling our voice solution. The i.MX RT solution is the first MCU-based solution powering AWS Alexa voice service solution running on micros. This is a form factor that in this specific example would allow you to enable voice commands into a light switch form factor. Imagine that you would have at this point in time a point of audio ingestion in every single recessed place inside a room. Would that be in a light switch enclosure, a smoke detector? You can truly envision the options of making your home a completely voice-enabled home with far-field detection and ability to actually stream commands up to the cloud through the AWS microservices. This, in turn, allows you to build things that work with Alexa or with Alexa built in, as the capacity of this form factor reference design would allow you to do so. Next example I want to take is the example of anomaly detection. We are all pretty much convinced about the benefits moving forward of machine learning. We're yet to understand, as we move from everything connected to everything monitored before everything becomes autonomous, how to make a decision based on data we may just not own yet. It used to be a cost consideration to understand which data to measure, which one to leave on the floor. Well, now we no longer have to make that decision. With the aggregation of sensors and machine learning algorithms running at the edge, you have the ability to monitor every single parameter drifting in ways that may or may not be supervised, but providing you with key information as to what has changed in times in order for you to understand which is the best combination of parameters to monitor, and for that matter, what are the best course of action to run through. This is where IoT Device Defender and IoT Device Analytics become extremely handy in their ability to ingest time series data, making educated decisions as to what the data should look like versus what it turns out to be. It turns out that every single home has similar expectations, yet have very different implementation. Your washer and dryer could actually be installed on a carpet that would provide very soft ways of managing the product, but it also may be actually implemented on tile floor where the vibration may create a different pattern when it comes to wear and tear. We want to make sure that every single device is capable of detect the change in its own environment, and similar to what Bart mentioned earlier, we have to constantly update those models, learn from the data collected in order to consequently improve its efficiencies. With this, you have the ability to monitor any kind of white goods or environments where integrity matters, in places where remote telemetry would provide you with a significant competitive advantage, in places where the telemetry that you collect will provide you to make actionable decisions when it comes to the insights you're gathering. In order for you to start these developments, we provided you with a form factor reference design that provides an i.MX RT solution powered by Amazon FreeRTOS, where the aggregation of sensors you see fit on that diagram provides you with probably the largest amount of sensor aggregation one can find in places where you do not know what to measure and what not. This provides you with a pretty interesting synthetic integration in order to anticipate data structures that you may not know upfront, but that you'd rather collect upfront in order to make sure that your instantiation meets your requirements. This form factor reference design comes along with connectivity and memory, which allows you to not have to reinvent the wheel on this implementation. It comes natively built in with Amazon FreeRTOS, which provides you with all the hooks and harnesses you need to trigger the anomaly detection functions we discussed earlier about, and then provide actionable insights to IoT Device Defender and IoT Device Analytics. Looking at how this is stacking up, Amazon FreeRTOS is the core component of this instantiation, where the connectivity to AWS is built in, where security is paramount in the way the device authenticates, and with predefined driver libraries for connectivity for Wi-Fi and Bluetooth Low Energy. We will then further partner with SageMaker and SageMaker Neo to further expand the capability with machine learning running on those devices in places where data ingestion points are augmented with local decision-making processes where inference engine can now run at the edge. A last example as we close this session is the potential of what we can do for a connected appliance. You see here that the relevance of this instantiation is not only worked in the home as much as throughout the whole value chain creation, from the device being manufactured, where logging information are being provided to the device, to its transport, to its final unloading to customers. You can prevent some anomalies by actually tracking the health of the package throughout, as well as in situ provide installer information and data uploads on need-to-have basis whenever any operations or maintenance operations are occurring. It's providing here a full lifecycle management capacity underpinned by AWS services in places where the onboarding capacity of just-in-time registration alongside the anomaly detection and analytics services are providing you with a fully manageable set of devices and fleets of devices in places where you can get now actionable insights coming from the data sets that are being collected at every single touch point from manufacturing to actual usage in situ. I want to thank the team for the opportunity to present today and hand it off back to Ian.
Thank you very much, Jerome, and thank you, Bharat, for your insights. So as we close out the session, I'll just summarize what we've went over. We've learned how AWS IoT device services can be leveraged to innovate in the smart home application space for a variety of use cases, and how to really address some of the challenges and convert those to opportunities for differentiation. Bharat shared an excellent real-world example of how to innovate in the connected home space while future-proofing for tomorrow using Greengrass for the Cradlewise Smart Cradle device. And then Jerome provided a pretty comprehensive overview of some of the integrated hardware solutions that work with AWS IoT to meet, again, a broad array of application use cases in the smart or connected home space. So we'll just leave you with a few resources. Feel free to peruse these at your leisure. We've tried to provide a comprehensive list of AWS IoT relevant services, our machine learning capabilities with Amazon SageMaker, a link to Cradlewise, and some of the NXP solutions that were covered in the presentation. Once again, we'd like to thank our guest speakers, and thanks to all of you for tuning in.